Hello everyone. I wanted to give you a few other videos about the logistic growth. We kind of sidestepped that the other day where you had to derive the equation, the one about the guppies in the tank, and then also the one about the gorillas on how to derive that equation. But in order to do that properly, we need to look at something called partial fraction decomposition. And I'm going to give you two examples with that, and then I'm going to come back to those problems that we were talking about. So let's suppose that we're given x minus 12 over x squared minus 4x. So we're given a fraction where we have a binomial in the numerator and a binomial in the denominator, but this one happens to be a quadratic. If we notice here, that denominator can be written as x times x minus 4. And so this fraction actually comes from adding two fractions. It comes from something I'm going to call a over x and b over x minus 4. So when you add these together and get a common denominator, the original denominator must have been an x, and this must have been an x minus 4. So what I'm going to try to do now is figure out what a and b would be so that we end up with x minus 12. And the first thing I'm going to do is multiply the top and bottom here by x minus 4 in that first fraction. And in the second fraction, I have an x minus 4, I have to multiply that by x over x. So you can see that I'm really working backwards here as I would be doing if I were combining fractions and getting a common denominator. Now, notice that this denominator and this denominator is the same as this one. So that means that my numerators must be the same. So if the denominators are the same, now the numerators must be the same. Now, it's kind of like balancing an equation like you did in chemistry. We have ax plus bx minus 4a equals x minus 12. So notice that these two together, ax plus bx, has to equal 1x. So that means, I'm going to use this little symbol here, therefore a plus b has to be equal to 1, because these two coefficients of the x have to add up to 1. But we also know that the constant part, negative 4a, has to be negative 12. And so now I can find out that a is 3, and once I know that a is 3 plus negative 2 equals 1. So when I go back to the original problem, I know that a would be 3, and I know that b would be negative 2. So I have broken up this fraction into two other fractions, and that'll help us with those problems about the guppies and the gorillas. So now let me show you a different example. We have 2x plus 16, and if you want to look at these examples, the problems, I got these from page 375 on the logistic growth section. But let's take 2x plus 16, and then we have x squared plus x minus 16. What I'm going to do is break that up into two fractions. This factors as x plus 3, x minus 2. So I'm going to write this as x plus 3 and x minus 2. I know that those are the fractions that this must have come from. Now, I don't know what the numerator is. I'm going to call that a, and this one b. But now, in order to combine fractions, I need to multiply to get a common denominator. So this would be x plus 3, and now I have x minus 2, x plus 3. So over here, I need to multiply by x minus 2 and x minus 2. And now, notice that my denominators are the same. So if the denominators are the same, then the numerators must be equal. So on this side we have 2x plus 16, and on this side we have ax minus 2a, and over here we have bx plus 3b. Okay, now let's combine like terms. We have a plus b x, so I'm combining my x's together, and that's going to be equal to 2x plus 16. And then over here, I end up with negative 2a plus 3b. Okay, now let's balance this. A plus b has to be equal to 2. So a plus b is equal to 2. And then my negative 2a plus 3b has to equal 16. Okay, now I have a system of equations, and the easiest way to solve this is to multiply that top one by 2. And that gives you 2a plus 2b is equal to 4. And now when I add these equations together, notice that the a's are eliminated, and I get 5b equals 20, so b equals 4. And if I go back to the original equation, I have a plus 4 equals 2, so a equals negative 2. So that tells me if I go back to my original equation up here, I know that a is negative 2, and b is equal to 4. Okay? Now, we're going to use this method of partial fraction decomposition in order to come up with those equations that we were wondering about, that I actually skipped over, and I told you that we would come back to them in problem number 33 and number 34. So now I'm going to go to number 33 and 34. What I do in 33 and 34 will not make much sense unless you've looked over on these for a little bit.